Hello, this is DASS project of Team 25. So the problem statement here is build a prospective list of customers based on ideal customer profile. So members of this team are Astitva, Sachin, Trisha, and Vivek with myself. So now why, what this software system is about? Now thing is like when you have a B2B business or any business for that matter, there applies a 80/20 rule. What the 80/20 rule says that 80% of your profits come from the 20% of your consumer base. So now for this thing, instead of it doesn't make sense to spend resources over all 100% of the consumer base, because you might end up spending more money than earning overall. So it becomes important to narrow down your scope of marketing, and this is done by certain filters. So once you have the 20% of your consumer base, the ideal 20%, you can minimize effort while still maintaining good amount of profit. So now this screening process involves a filter. Here in business terms, we call that filter an ideal customer profile. So ideal customer profile is essentially a set of filters, and it basically works by eliminating all the potential customers which don't fit that profile. So then so, how would a software system help with it? The point is now, even after you've narrowed it down, so for a small startup or a small business, it is much convenient to hire an employee to sort through the 20% of the targeted 20% of the consumer base and market to them, see if they fit their profile. But as a business grows larger, this problem becomes exponentially more complex because you have much larger region, much larger domain, you know, much more products to sell. So for larger companies, it makes much more sense to automate it. And by automating is that this is the target this software system has. Um, okay. So now the plan is now, at this point, data is basically a currency. So our startup is about collecting data from the potential customers, the 20% of them, so that you don't waste your resources on trying to approach the 80% of them, which won't give you much profit anyway. So so by collecting data of all the startups that of a certain domain that you'd be interested in, and filtering them through the ICP. So here we can see, so there are different kind of sources on the web. So company websites and their public data feeds on websites like LinkedIn, Crunchbase, and Startup Tracker, places like this, and press releases and news articles on them. So what a software system tries to do is scroll through these websites, gather as much information as they can, and store it in a database. And the web app would then represent that data in certain UI format. So the person who wants to sell the product as a B2B business owner to other businesses, this becomes a much easier task. Implementation. The implementation of this we can break up into 5 parts. First part, which is one of the hardest parts, is finding the data sources. Now, as since data is currency, all the startups or companies which target on collecting data have a certain monetary value on the data. So this is why you have companies with a certain freemium models where only a limited number of data is free for you to access. Otherwise, it's hidden behind a paywall. So finding sources was an important task to find all open sources to and find sources which provide a sufficient and reliable information. Second was ways to extract data. Second part, this refers to not all websites provide an API to just hand you over the database. So some websites do hold an API, some websites don't. So accordingly, we have to scrape some websites according to the terms of service so that uh, we don't uh, violate them. And then integrate the third part, integrating data from chosen sources into a single database. Now this is a problem. Why? Because different sources have different ways of organizing data. Now all data from all those sources, organizing them into a single database would be challenging because all those databases share a different schema, and so that was uh, a big step. Then the backend, in backend we implement the basic functionality, uh, the core functionality of the system, where we call crawlers and um, write APIs for the front end to use. Um, and the fifth part is the UI, which is the most important as for end users, which connects to the APIs of the backend. And
Hi, this is Sachin, and I'm going to take it from here. Most of the lead generating apps are premium or freemium. Since we had to make it free to all users, we had to eliminate these apps from the bucket. In the very few open data resources, most of them would not provide API to extract data. So we have to do an exhaustive exploration of these resources, had to go through many lead generating apps and open data websites to pick a reliable resource, because many open data resources aren't much reliable to trust. We had to pick multiple resources for reliability or to cross-check the data we obtained. And when we do this, the multiple resources will be having overlapping data with different attributes and data forms. So we have to pick the resources in such a way to eliminate resources which are in conflict and integrate which those data types into a single database. Now these data types can be in different forms like CSV file, JSON file, or just shown in the web pages. We had to pick a single form for better generation of data. So we picked up single web pages as our primary resource. To extract data from web pages, we used spiders or web crawling bots to crawl data from these resources. For this, we use scrapy module for spawning those spiders and limiting them to the domain of selected resources. We faced some problems with in the terms of resources to allow these bots to scrape their data. So we had to modify these bots to look as the browsers asking data for the user.
Okay, so as we've seen, we have gathered data from different sources, from different websites on the web, and now it is our task to integrate all the data into and dump it into a single database for further use. So, as we've seen, for the R1 release, we plan to prototype, which would allow the user to search for schools and startups in different regions, including countries, region as in the country, and different domains for a startup, and also for further, after R1 we have planned to add more research types. So according to the model, we have one database and it has two schemas which will be joined together to extract required information. And um, then we come to the backend part. The backend part is has a lot of components, like we added the Google authentication to authenticate our users and allow them to enter and start their sessions. So and then there are requests. You're putting a lot of get and post requests from the front end to the back end. Also, the crawling part used Scrapy to crawl the web to get the database. So this is the UML diagram for our project. And then the UI design can be broken down into a lot of components. The login component allows the user to log in. And then there's a navigation bar, which mostly, we have used Bootstrap for it. The search component, which allows the user to enter the search phrase. As in the prototype, the schools for this startup, then there's an attribute to it, and of course, you can you can actually search for the following, the above school or startups. Then as you've searched, it will take some time, and then after some time you should get to see the results. Also, every user can see the previous histories, his own profile, and log out. These are the use cases of the user or the functionalities what the web app will be able to do.
Hi, I'm Asthitwa. I'll talk about the firstly about the technologies that we use in our project. For database, we use MongoDB, which is a documented database, and we integrated it with Node.js using Mongoose package. For handling Ajax requests like get and post, we used Express.js. For handling the front-end framework, we use React.js, and for integrating all these three, we use Node.js as our backend environment, and for integrating all these. And for scraping the websites and getting the data for the database, we use Scrapy. Uh, Now let's talk about the timeline of the project. For sprint one, we firstly gathered the information about our project and the requirements that we need, and also performed feasibility study. For sprint two, the documentation and design doc was completed, and SRS was created and was later verified by our client, along with further resource gathering. For sprint 3 and 4, that mainly included of implementation, and we implemented many features like Google sign-in, user profile, logout features, integration with backend and scrapy, and also rudimentary UI. And for sprint 4, we just made the UI better and enhanced, like we implemented search results, added domains, and many other features. Now let's see how the login thing works. We'll click on the button, then we get logged out. Now let's see how the search thing works. We create a firstly a new search for startups. Enter the name startups in the search field. Then add domain. Here we take AI as our domain, and then add country. Here we take India as a country, and then click on search. A new search result will be posted after some time. Yeah, and then we click on show result to show all the obtained results, and then we'll go back to the main page by clicking stealth mode, and then add a new search for searching for schools. And here we don't need to enter like domain and country. We can directly search, and it will automatically search for Hyderabad and country as India, and click on show results to show all the obtained results. uh, Now this is how the previous searches are shown. Like we have shown it already. All the previous searches appear in a list, and we can click on show result to show a particular result. All these searches were sorted according to the time. The newest ones come at the top, and the oldest one come at the bottom. Now we'll talk about the road ahead.
For future, we plan to expand the system to include much more sources for a certain search phrase, and include much more domains to include variety. And that would be all. Thank you.